Hi, everyone. I know everybody is waiting to just get it over with. I won't take that much time, I hope. My name is Shilpi Yadav. I am a solution architect at IBM. Over past 2 decades, I have worked on enterprise ERP modernization, especially in digital transformation for large enterprises. So the lessons I have learned, the experiences I have gained, and all the strategies, the patterns, the architecture I have used is I'm going to bring into today's topic. You will see it's not zero downtime deployment or migration strategies because it can never be zero. It has to be a little bit, there has to be a little bit downtown. But how do we achieve that? So the thing is, how do we achieve the ERP modernization without disrupting the business? Because at the end of the day, it is about money, it's about patient data, healthcare data, anything. So we cannot bring down the system. I'm going to talk about what we have seen, but what I have done over the years. So enterprise, they run very critical systems, even healthcare, your finance, supply chain, anything. But at the same time, when we are running today on the server, when they're running on the on-prem server, we cannot avoid cloud transformation, hybrid cloud transformation. We cannot avoid making them leverage cognitive capabilities in the system. But when we talk about legacy system, the traditional systems, when we have to upgrade them, they need very long downtime, or they are very complex, they're very robust. It's not only one server, it's a connection, it's kind of web. You have multiple applications. So how do we achieve that? When we talk about the modernization problem, it's basically, if you change in any one server or in any one system, if it is not properly deployed, it can cascade and it can lead to problems in further applications. And at the same time, we cannot avoid it because we have to leverage, we have to scale our data platforms. We have to go further to the cloud. We have to, whatever are there, we have to enhance it step by step. So what is near zero downtime deployment or migration? It means systems and upgrades, they happen, but the business keeps running. You keep the transactions, the data, they keep on running. So how do we achieve? The common strategy which we generally use, the very, very generally, is a parallel environment. We have the old system running and we have new system we deployed. We do blue-green deployment, which is your old server and new server. We do the data synchronization, and when everything is replicated, reconciliated, we do a control switchover. There is certain architecture pattern where we use. We have to consider certain layers. First, what is your core layer? Your on-prem, your legacy server, your middleware, your ERP systems, whatever are your sources, you define that. Then what the data replication layer, your messaging layer, your database server layer, your synchronization. Whenever the data is there in the old system, it has to be synced to the new system also. A new target system is deployed. It could be anything. It could be on hybrid cloud or anywhere you want to do. Even for the product migration, sometimes new product, when it is moving to CP, let's say the cloud, it's completely phase over. So we need another layer, which is your target environment. Data reconciliation. If data is bad, everything is bad. Because if it's not clean, if it's not going as such how it was going in legacy, it's going to create issues. And then a very controlled, means the cutover doesn't happen all at once. It also happens in phases. I'm going to talk about mainly 3 patterns which we use. Very, very common, very widely used is the blue-green and parallel deployment. It means you have one system which is already there. You develop new infrastructure, you develop new parallels. It's kind of like clone, but not exactly that clone, but it's like whatever you are running there, you are going to move into another system. You create the new system. It could be anything. I just gave an example of AIX, Z-Linux, but you can relate with any other system, any other server over here. Then when the server is ready, when your programs are moving, you are also doing a data replication. Whatever our data sets are being used in the old server, you have to get it replicated to the new server. The programs, how it was running, how it is running now. At each stage, you do a check and you do a reconciliation. When both systems, you are ensured that the data which is flowing is actually flowing through the new system also, you are like, okay. Once validation, testing, everything is completed, then you do a cutover. where after running for certain months or whatever is your duration, you decommission your old system. Another pattern is when instead of doing everything at once, because ERP, the system is not about one server, as I said, it is a collection of multiple servers, multiple systems, multiple applications. Sometimes there are thousands of applications. There are almost like 500 servers at the back end. So you do either a group of servers or you do server by server, you don't move all at once. You move one phases and phases. How it helps is some of the server could be running in on-prem and some of the server will be running in your new cloud. But you have both of them running, so your business will keep on running. It will not disrupt, it will not stop at that time. Also, because of that, the disruption will be very, very minimal because you have some things running in the old system also, something running in the new system also, even though it's a different server. But at least you're getting the output. So we migrate piece by piece rather than we are doing a full, all the server at once. And one which is widely used is phased cutover. You do unit by unit or you do geography by geography. Let's say you want to do APAC, or maybe you can do country within certain zone. If you see something is there, this also helps in detecting early issues. Let's say you have enrolled for APAC and you got to see some issues and related to, let's say, multi-byte character or the kanji character or something. You realize, okay, your program is not running as well in the new server. You create that structure, configuration requirement, and then when you move to different geo, you have that lesson learned. So you can do by unit, by geos, or you can do by business units. You can do by applications. You can do by services. It all depends. You can do by modules. You can do by HR. Finance moves at one place. HR moves at one time. It all depends on how your business is working. You can split it down. You can do a phased migration. But when I talk about all three migration, the most widely used by all system is the combination. You can do a phased migration, plus you do a parallel deployment. So you're using two patterns at the same time. It's kind of hybrid. That is the most widely used approach by any enterprise, because enterprises, they deal with huge volume of data, large number of customers in millions of transactions per hour. So it is best to achieve in a hybrid approach. These are all the strategies, but I'm going to talk in detail about the use cases. I have 3 use cases I have come across, which I have done over the years. It's not now. This was, I believe, 7 years back. I don't remember the time. So this is, there's an ETL here. We are actually migrating this middleware transform, which is your infrastructure data stage. It runs, there was a requirement that we have to move it from on-prem to cloud, plus we had to do a major product migration, and that product was completely new phase. But it was so complex because there are hundreds of interfaces which runs through data stage. It connects to so many servers for database, for SAP, for your MQ. They're extremely widely complex network. It transforms all the data. So we cannot avoid doing all at once. What we did was, we have production, we have quality, we have development server. This is our current server. We started with the new one. First, we came up with the requirement. Okay, how many jobs are there? How many interfaces are there? How much data it is processing? That kind of all the t-shirt sizing we did, how much CPU will be available, what kind of infrastructure we need, the encryption, the protocol, everything. It was ready. We see, okay, do we need high availability server? Do we need to have disaster recovery server? Which data center should we do? All these things base work was done, and we started with the development. We created that structure. At this moment, there is only configuration. There's no data moved, there's no interfaces moved, there's no program which has been moved. Once that is ready, we replicated NFS server, MQ server. We actually, because those are already in the on-prem server, they are not migrated. We moved that, we created those catalog connection in the new server. We kept all the configuration and connections ready. Now we have to move program by program, or we have to move interfaces by interface. What we decided was to go with the functional domain. Let's say finance, general ledger, or let's say from HR. We wanted to move certain component by that domain by domain. We started, so we already have this system running. We started moving it. Now, when we move it, we realized there were certain issues which were coming. We started fixing it. We learned the lesson. We applied it for the next domain which we're going to move. But now, how do we prove that whatever we have moved is working as such? We did regression testing of the data set which was used for the old server and the data sets which we are using for the new server are the same. The data which is created by the old server and the data which is created by the new server is same. It's at the very, very minute level we were doing the testing. Plus, the second testing was from source all the way down to the target. It means not only through data set, when it connects to, when it makes a customer translation call, when it does a mapping service, everything was validated that time with the same source data and the target data. So that at least we are ensuring that both the data are same. At the same time, we were also checking a performance. Sometimes it is by default assumed when we are moving to new version, oh, you're going to get a good performance. Not always, not all the time. We had to do certain simulation in the new server to see. When we saw it is okay, we started moving it. When we saw this is almost like 50% done, we started creating the QA server. We started with the infra. We started moving the whichever have been validated or good. We started moving that in the QA interfaces. Now imagine you have, I'm just giving a picture, you have 500 interfaces here. I have like from 500 in the development, I have moved now hundreds. When I moved my hundreds, I started moving 50 to QA. Now imagine, this is the thing. Now see an issue. My production is running. I got a very critical issue. But that's why my old system is now coming here into picture, because I have to work in that old development, and then I have to move it to QA, and then to move it to but now the change which I have done, I have to move it to my new server too, to reconcile. If I don't do that, I'm going to lose that thing when I go to production. So this complexity comes into picture. That's why we try to minimize the window when we are doing it, because they're so complex, doesn't complete in days or weeks. Sometimes it takes months. So we do that approach when we move to QA. We try to minimize a very, very small window. Same thing for new requirement. If there is anything which is coming, which we have to build here, plus we have to do the deployment here too. So that's why we started moving. When we went to production, we almost like we moved multiple domains and the functional units all together. So at the moment when we have 500, it started going down like this. There was like 300 here, 200 is already running in production. So at one moment, 300 are running in old server, 200 are running in new server. But the business doesn't matter to business, because they are receiving data, whether they're receiving from the old on-prem or they're receiving from the new server. And then in the end, when we see, okay, it's all good, everything running not only the data, but the performance, then we moved and, I'm sorry, I did not move to next website. Okay, so then we decommissioned that system. That's how we did that. So when we were doing it, we realized how many things were there, the data set, the regression testings, the CR things, all these things were the lessons we kept on learning. And we used that when we were moving for different domains or different interface a batch. This is another use case. So SAP ECC to S/4HANA. ECC is going out of support in 2027. This is one single source of truth. In IBM, we have a program like we do for the internal. It's a one of the major ERP system which is running, and we had to move it from ECC to S/4HANA, which was done a year back. But it deals with almost like 150,000 users. It deals with millions of data. It is so critical because it's a single source of truth. It cannot avoid downtime, but it cannot avoid the upgrade as well. So what we did was we adopted a same phase migration. We created a shell. So the SAP ECC system which was there, we created a shell of that system, created an empty, we defined what we need to move, how we need to move, what can be cleaned. Now, at this moment, we were cleaning the data also. Remember, legacy systems which are running for 2 decades, some have been obsolete, but we never realize it. When we're doing the migration, we realize, okay, these are not really needed at all. So that time, we did a selective data filter, and then we created a system architecture. After that, we started from the SAP system, which is there, the legacy system, and then we created an empty shell for that. That empty shell was nothing but with the configuration. There was no master data, there was no transaction data at that time. After that, we did a system conversion from legacy to S4HANA. We moved that, and then we did a selected data transfer. We migrated and selected certain data, master data, your transactional data, and you kept on moving one at a time. When we were moving it, all the applications which were connecting to ECC, your middleware, your all other applications, your web services, all were being tested same way for regression test, for your business validation test, for your performance test, because each and every stage takes so much time. Again, we did by units like HR or the finance data, QTC. We moved it in the phases because nothing was, since these are such huge systems, it's not recommended to do all at once. But it is also not recommended to keep a very long time frame, because something could come in between and then you have to stop and work on that, and then you have to, so we try to minimize that window also, but they are always, it took almost I think a year or so to complete the whole migration, but that's how we achieved that. Okay, this is, we have, this is before we moved to S4HANA. This was, we have SAP BI, SAP CRM, SAP ECC, middlewares, your data stage, your ACE, you have IEB, you have for your database server, MQ servers, many, like almost like when I was working, I recognize it as almost like close to 300, almost like 400 servers were there, which we had to move. I'm not talking about application. The servers it runs. The scheduler also runs at the backend server. I'm talking about those servers when we had to migrate. Even when SAP ECC runs, the backend is at the server. We were migrating from on-prem to hybrid cloud migration. Again, it deals with so much volume of data, and also it connects to so many applications. It gets data from either bank, it gets data from multiple applications, it has to send it out. Those cannot be stopped. But at the same time, we cannot move all at once. We had to do, again, server by server. We identified what all server I will move. I'm now not talking about even the programs and everything. I'm talking about which all server I will be moving. Let's say, so I realized that one of the very widely used server was NFS, your shared mount path. Every application was writing to that server. Okay, let's start with that. We move that, we mount it, we see how it was there, copied all the configuration which was done at that level. We see how it is there. Once that is okay, we move another set, let's say databases, or let's say I'm moving databases plus my messaging server at the same time. But I'm applying the same concept. So the concept remains the same. You actually build another system, you actually move there, you validate, you do a reconciliation, you check each and everything. When I'm moving it, I'm not only validating that server or that application, I'm also validating the application using that server. I'm actually going through everything, like when I read my data, when I saw it, when it was transformed, and how it was loaded. So it's not only, okay, my data has been moved, I have mounted it over there. No. Again, we have to do regression testing for each and every stage. We moved database server, MQ server. We went step by step. We moved another middleware server. Scheduler we moved. Once the scheduler is moved, all the application it was connecting, the SAP system, your middleware, your all other system, it has to be reconfigured, it has to be re-established and see how it was going. Then in the end, we moved SAP system, another BI system. When everything was done, it was done over a period of time. It took almost more than 2 years. I forgot about it, but it took so long. It took so long. So that was the, that's how we did, step by step. We did server by server. Because when we talk about only one application, it is easy to do. Let's say you only have to move your databases. But I'm talking about databases, where it is connecting to, how many applications are using it in the whole ERP domain. So what do we learn? We definitely can do modernization without disrupting the business. Deployment, zero-town deployment is not really a tool. It's actually your architecture, your strategy, your pattern, how you create it, how you define it, how you do it in your business. It all depends which phase migration you have to do, or you have whatever you implement, you just have to be consistent in that. Identify the data volume, identify the units, or whichever way works for you. And the key is parallel deployment. That's what we realize it works well. Because when you have another system available, let's say something goes wrong, you can still have the running system and you can make the change over there. And you can still send the data to business. You're not blocking the data. So that remains the same. Data synchronization, extremely, extremely, extremely important, because data is the key. Anything happens in the data, it cascades down to each and every layer, disrupt everything. You may not realize it at that time. Even when we migrate, when we do an integration, you may not realize it at that time, but later on when the report generates and you realize, okay, this order is being generated, which has been closed, then you realize something has gone. Now, so that's why it is important to do reconciliation and validation at every step. Let's say you have moved to this step, this interface or this program or this server, ensure it is tightly checked at every phase. And then incremental migration, the phase along with parallel is what helps. And with this, I conclude my session. Okay. Thank you.